Welcome to the Economist in Your Ear podcast. Today, we're jumping into a topic that truly captures our collective imagination: the quest for longer, healthier lives. Specifically, we're going to unpack the fascinating world of longevity drugs with a sharp focus on two molecules, rapamycin and metformin, and how they stack up against, well, the age-old practice of long-term fasting.
Right.
You see, while going without food for extended periods has shown remarkable promise in extending lifespan in animals, the allure of a chemical alternative, a pill that mimics those benefits, is undeniably powerful. I mean, who wouldn't want to avoid the constant hunger pangs?
It's certainly the holy grail for many, isn't it? The idea of getting the benefits of calorie restriction without, the restriction. It's incredibly appealing.
Exactly.
The Economist recently gave us a valuable snapshot of where things stand, but our mission today is to go beyond just summarizing their findings.
Yeah, we want to dig a bit deeper.
We want to offer you a critical interpretation, maybe challenge some of the assumptions, provide deeper context with the newest data that has emerged, and explore some angles that might have been underrepresented.
To give you a truly nuanced understanding, okay, let's jump right into the core of this. When we talk about longevity and interventions, it almost always starts with calorie restriction, or CR.
That's the foundation.
It's a fundamental piece of this puzzle, demonstrating that near starvation, basically when done correctly, can significantly prolong lifespan across a huge range of species. We're talking everything from tiny worms all the way up to monkeys.
Right. The evidence in the animal kingdom is pretty definitive. And it's not just about living longer. It's about the underlying biology.
The how.
Exactly. Both rapamycin and metformin caught researchers' attention because they target what's known as the mTOR pathway.
Okay.
This pathway is crucial because its overactivation in old age is directly linked to hallmarks of aging, like inflammation.
Yeah.
But when you fast, you suppress mTOR activity.
No, it's good.
It seems to be. Suppressing mTOR promotes autophagy, essentially a cellular cleanup process. Cells get rid of accumulated junk.
Tidying up internally.
Exactly. And that cellular tidying up is really thought to be lifespan enhancing.
And it makes perfect sense why these two specific drugs became such hot candidates then. They have some serious practical advantages.
They do.
For one, both rapamycin and metformin have already undergone extensive safety trials for their main jobs. Rapamycin as an immunosuppressant, metformin for diabetes. So lots of safety data already exists.
Which is a huge plus.
Plus, they're off-patent. They're incredibly cheap.
Sounds like a win-win, right?
It does, but that off-patent status cuts both ways, as The Economist rightly pointed out. It's a huge hurdle for commercial funding. Pharmaceutical companies aren't exactly lining up to fund massive human trials for a drug they can't really make big profits on.
Right, no exclusivity.
Precisely. And this is why the Targeting Aging with Metformin, or TAME, trial, which got FDA approval way back in 2015, has remained, stuck. Stalled purely by a lack of funds. That's so frustrating. It's like having the potential answer right there.
But no one to pay for the final checks. It's a real bottleneck.
Right, and rapamycin hasn't fared much better in that regard, at least initially. The Pearl trial, participatory evaluation of aging with rapamycin for longevity, that started in 2020. But The Economist's conclusion, which got a lot of press, was that it found no strong evidence that it worked. So for a while, it seemed we were stuck mainly with animal studies. Interesting, but...
Not humans.
Yeah.
And on the animal side, the conclusions presented in The Economist from that aging cell meta-analysis, the one led by Edward Ivam E. Cook, they seem pretty clear-cut.
What did they say?
Basically, calorie restriction works. Rapamycin works pretty much equal to CR, but metformin does not.
Wow, that's blunt. Metformin does not work.
That was the big headline for many, and it understandably sent shockwaves, especially for people already using these drugs off-label,
Yeah, I bet. And some prominent figures like Brian Johnson, who's famous for his extreme longevity quest. He actually dropped rapamycin in 2024 because of side effects.
Right, things like lipid and glucose issues, heart rate.
Increased infection risk, too, apparently. So for the rest of us, mere mortals, The Economist's advice was, maybe predictably, stick to the basics.
Eat well, don't drink too much, exercise, sleep.
Stop smoking. Solid advice, sure, but maybe not the magic pill people were hoping for.
Indeed. But hold on a second, because the plot thickens here. That seemingly clear-cut picture, painted by The Economist, it's not quite as settled as it first appears.
Okay.
And this is where we really need to layer in the nuance and some newer evidence. Let's start with that June 2025 aging cell meta-analysis.
The one that said metformin doesn't work?
That's the one. Now, it did confirm CR extended median lifespan by about 19% and rapamycin by about 17% across 167 studies in vertebrates. That's solid.
Seems pretty equal, like they said.
But, and this is crucial, this applies only to controlled lab species, not free-living humans.
Yeah.
That's a really vital distinction we can't ignore.
So that distinction between a sterile lab cage and, our world is really important.
Absolutely. Lab mice are shielded. We aren't. But what about metformin, the one the economist flatly said does not work? You said that needs nuance, too.
Yeah, that seemed very final. What are we missing there?
Well, that blanket statement doesn't quite hold up. The meta-analysis, when it said metformin didn't show overall benefit, it kind of missed a key point.
Which was?
Animal studies frequently show that metformin does help, but often only in metabolically unhealthy models, think diabetic mice, for example.
Ah, so it depends on the starting health of the animal.
It seems so.
Yeah.
And the data for those specific conditions were actually underpowered in that big review. They didn't have enough studies focusing just on the unhealthy ones.
Gotcha.
And even more importantly, there's a huge update on the TAME trial. Remember, the one stalled for lack of funds.
Yeah.
AFAR, the American Federation for Aging Research, they relaunched fundraising in April of this year.
Yeah.
And the NIH actually granted a $45 million matching award.
Wow. That's serious money.
It is. It's conditional on getting pharmaceutical co-funding, but still. It strongly suggests the idea that metformin is dead for longevity is just wrong. It's premature. There's still strong belief in its potential.
Okay, that's a massive turnaround for metformin's prospects then, especially since it's already so widely available and cheap.
Exactly.
So what about the Pearl trial for rapamycin? The Economist said, no strong evidence. Did that picture change too?
It has, quite significantly, actually. We now have the one-year data from Pearl. This looked at 463 adults, median age around 69.
Okay, real people, older adults. What did they find?
They found that low-dose rapamycin, specifically 1 milligram, 3 times a week on weekdays, it modestly improved gait speed, how fast people walk.
Which is a marker of health span, right? Frailty.
It is, yeah. And it also improved self-rated vitality, how energetic people felt. Now, there was a mild increase in LDL cholesterol, about 12%.
The bad cholesterol.
Right. But overall, adverse events were reported as mild. This isn't a null result. It's not no strong evidence.
It sounds more like subtle positive signal.
Exactly. It suggests genuine health span signals, maybe without major immune compromise at this low dose. It's a much more nuanced and, frankly, more positive outcome than the initial report suggested.
So Pearl wasn't a bust. It was, well, a nuanced finding. Which brings us back to that idea that the simple headlines often miss the critical details.
They really do.
Like when The Economist said CR and rapamycin are pretty much equal, you questioned that earlier. Is that really the whole story?
It's a great question, and again, it depends on what aspect of aging you care most about. While the median lifespan gains might look similar in some studies.
The average increase.
Right. Calorie restriction still consistently seems to outperform rapamycin on maximum lifespan, how long the longest-lived individuals live, and also on disease delay metrics in several species. So equal is probably an oversimplification.
Okay, so CR might still have an edge depending on how you measure success.
Potentially, yes. Then there's the side effect profiles, a deal breaker argument against rapamycin.
Yeah, the infections, the metabolic changes.
But that often assumes a fixed, usually higher, dose and schedule, like the ones used for transplant patients. But dose and schedule absolutely matter.
How so?
Small trials are now showing that low-pulse or once-weekly regimens can dramatically cut that infection risk. So making blanket risk statements is misleading.
So lower doses, less frequent? Might be safer.
It seems that way. In fact, there's a registry tracking about 333 people who self-prescribed rapamycin for longevity. Over 2 years, less than 5% stopped because of side effects.
Less than 5%? That's surprisingly low.
It really puts the risk perception into a different light, doesn't it? Suggests the risks might be manageable with the right protocol.
That's a huge point. The risks seem way less scary when you talk about these specific lower dose regimens. Okay, what about the broader assumptions? Translating animal studies to humans. That seems like a minefield.
It really is. And there are a few key assumptions worth challenging. First, this idea that lab lifespan equals real-world longevity.
We touched on that, the sterile cages versus our germy world.
Exactly. Rodents in these super clean cages are shielded from most pathogens. In our world, which is full of bacteria and viruses, rapamycin's immunosuppressive effects could potentially backfire for some people.
Making them more vulnerable.
Potentially, yes. So what works perfectly in a lab bubble might not translate perfectly to messy real life.
That makes total sense. It's easy to forget how different their environment is. So if lab equals real world is flawed, what's another big assumption? You mentioned the idea of a single silver bullet.
That's the second one, yeah. This assumption that longevity is about finding the one magic drug.
When aging is so complex.
Profoundly multifactorial. And the science is increasingly pointing towards combination therapies.
Using multiple drugs or approaches together.
Exactly. For instance, a recent Nature Aging paper, just from May 2025, showed that combining rapamycin with another drug called trametinib, it extended lifespan in mice by 30%.
30%. That's way more than rapamycin alone, right? Which is usually like 15, 20%.
Significantly more, yes. It hints at multi-pathway synergy. You're not just hitting mTOR, you're hitting other pathways too, like MAPK in this case, another key signaling network.
So we're moving beyond just mimicking fasting.
We are, and it's not just these two. We're seeing emerging competitors. Things like GLP-1 analogs. Those are the drugs making headlines for diabetes and weight loss.
Like Ozempic.
That class of drugs, yes. And also senolytics compounds designed to clear out old dysfunctional zombie cells.
Clearing out the dead wood.
Kind of, yeah. Both are showing promising lifespan gains in early studies. So the field is broadening way beyond just rapamycin and metformin.
So less about finding the pill, more about finding the right cocktail, maybe.
Or the right combination of interventions, yeah.
Yeah.
It makes sense given how complex aging is.
Okay, and what about behavior change? The economists seem to write off calorie restriction as just too hard for people. Is that fair?
Well, that's the third assumption, that serious behavior change is basically off the table.
Wow.
While strict, continuous CR is very difficult, yes.
It sounds miserable.
It can be, but the article's final advice, eat well, exercise, etc., feels a bit contradictory if you think CR is totally impractical, right? Lifestyle is behavior change.
Good point.
And maybe it's not all or nothing CR. Intermittent fasting or diets restricting specific things like protein might be far more sustainable for many people.
Easier to stick with.
Right. And large studies are actually showing neutral or even beneficial heart outcomes with some forms of intermittent fasting. This contradicts some of the more alarming headlines you might have seen from studies like the NHANES analysis.
Okay, so behavior change in different forms is definitely still relevant.
Very much on the table, I'd argue.
Okay, and assumption number 4. That hurdle about off-patent drugs having no commercial pathway for funding, is that always set in stone?
That's the last big one. Off-patent means no viable commercial path.
Yeah.
But we have history here. Think about statins.
For cholesterol.
Exactly. They became low-margin generics pretty quickly, but we still saw massive widespread trials that completely changed heart disease treatment.
So it can be done.
It suggests that creative funding models could work, maybe combining NIH grants like we're seeing with TAME, plus philanthropy, or even developing combination patents, patenting a specific pairing of old drugs for a new use.
Ah, clever.
It could potentially bankroll the large human studies that rapamycin and metformin really need. The problem isn't necessarily insurmountable, it just needs a different, maybe more collaborative approach.
That really paints a much more dynamic and frankly hopeful picture than just reading the headlines. So how should we think about rapamycin now in this bigger picture?
I think it's useful to see rapamycin not just as a potential longevity drug, but as a proof of principle.
Proof that what works.
Proof that pharmacologically nudging these key nutrient-sensing pathways, mTOR is the famous one, but others like A and TK are important too, can genuinely move the needle on aging biology.
So it showed it's possible to target aging with a drug.
Exactly. Whether it or metformin ultimately becomes the sort of aspirin of geroscience, a widely used, effective, safe intervention that really depends on several crucial next steps.
Okay, what are those next steps? What do we need to see happen now?
Well, first, we absolutely need those large human trials. But importantly, they need to be anchored in biomarkers of aging and look at multimorbidity. Meaning not just tracking lab numbers, but seeing if the drugs actually delay the onset of multiple age-related diseases, heart disease, dementia, cancer, etc., pushing back that cluster of conditions.
Right, delaying the bad stuff, not just changing a number on a test.
Precisely. Second, we need stratified dosing protocols. We talked about this, finding the lowest effective dose, maybe intermittent schedules, to maximize benefits and minimize those side effects.
Tailoring the dose.
Yes. And third, more combination pathway studies. We already know synergy works better in mice hitting mTOR plus APK or mTOR plus AMPK. That's where the really big breakthroughs might come from.
Combining forces. And finally, what about the regulators? The FDA must play a huge role here.
Absolutely critical. We need a clearer regulatory pathway for what are sometimes called aging-adjacent indications.
What does that mean?
Right now, drugs are approved for specific diseases. The FDA's openness to approving a drug for delaying multimorbidity or treating aging as a condition itself, it's still tentative.
They don't officially recognize aging as a disease you can treat.
Not explicitly, no. That's why the TAME trial is so important. If it gets fully funded and succeeds, it could set a massive precedent. It could pave the way for future longevity drugs to be approved specifically for targeting the aging process itself.
That would be a monumental shift, wouldn't it? Treating aging like we treat high blood pressure.
A complete paradigm shift.
Okay, so wrapping this up then. It sounds like The Economist did a good job highlighting rapamycin's promise, and maybe metformin's initial stumbles in some animal data. But the real story is way more complex.
Incredibly complex and nuanced, yes. The journey from lab worm or mouse to human application is long and full of caveats.
And the updated Pearl data, the new hope for TAME funding, the excitement around combination therapies, it all shows the narrative is far from settled. It's not just rapamycin yes, metformin no.
Not at all. It's much more dynamic. For now, though, the safest, most proven longevity stack still starts with the basics.
The boring stuff.
The effective stuff. The Mediterranean-style diet, getting good sleep, regular exercise, not smoking. These are still our foundational pillars.
Didn't argue with that.
But this knowledge should come with a healthy dose of skepticism about quick fixes. And just a real understanding that the science of aging is moving incredibly fast. What we think we know today will definitely be refined tomorrow.
Which leaves us with a final thought for you, our listener, to think about. As we gain more insights into longevity and these potential interventions become more real, what ethical questions do you think we as a society need to grapple with most urgently?